Hi, my name is Talia. I'm a high school senior and I'm super passionate about teaching others chemistry and math. This YouTube channel is a supplemental resource to anyone who may be having difficulty in their chemistry classes. This week, I'm going to be talking about ionic compounds, and that includes all different kinds of ionic compounds. So if you need help with those topics, keep on watching. And without further ado, let's get started. Okay, so I'm first going to do an overview on ionic compounds. So ionic compounds form between a metal and a nonmetal. So we know that in an ionic bond, electrons are transferred rather than shared. And this is the same case with an ionic compound, because so the nonmetal is going to have a negative charge and the metal has a positive charge. And the electron will be transferred from the metal to the nonmetal because the nonmetal will be more electronegative. So before we go into the different kinds of ionic compounds, we are just going to practice drawing some Lewis structures of ionic compounds so that I can show how the electrons are transferred. So first we have magnesium and oxygen, and we've drawn Lewis structures multiple times. So I'm just going to draw the valence electrons. Oxygen is more electronegative than magnesium, so the two valence electrons are going to go from magnesium to oxygen, and then magnesium is going to have a 2+ charge, and oxygen is going to have a 2- charge. And oxygen will also have 8 valence electrons because it got the 2 from magnesium, so the electrons are transferred. Now we are going to break that up into different kinds of ionic compounds, and we are going to start with simple ionic compounds. So these are just between a basic metal and a basic nonmetal. So I'm going to go into naming and writing the formulas for each kind of ionic compound we're going to be talking about in this video. So first with simple ionic compounds, and the naming, very straightforward. All you do is name the metal, then name the nonmetal, and you change the ending of the nonmetal to "ide." So for example, if we have MgO, as we did in this example, that would be written as magnesium oxide. Ga2O3 would be gallium oxide. Bas would be barium sulfide. So the metal name doesn't change. The nonmetal stays the same except for the end, which is changed to "ide." Now to write the formulas for simple ionic compounds, also very straightforward. Here's an example of me doing it over here. You are going to write the symbol and the charge for the metal, as I did here with Li+, then the symbol and the charge for the nonmetal, which I did with Br-. Then you're going to use the charges of both the metal and the nonmetal to determine how many of each element, how many atoms of each element you need in order to make the overall charge of the compound neutral. Because remember, compounds, unless they're polyatomic ions, are neutral. So I only need a +1 and a -1 in order to have a neutral charge. So the compound would be LiBr. We can see the same thing with CaI2. So calcium has a 2+ charge. I wrote the symbol and the charge for the metal. Iodine has a -1 charge. Here's the symbol and the charge for the nonmetal. And then here I am using the charges to determine how many atoms of each element I need. So as I wrote here, we have a +2 and a -1. 1 atom of calcium is required and 2 atoms of iodine are required, because that'll be a +2 and a -2. And then I'm going to write my final compound, calcium iodide. And that would be it. And you use when you're writing the formula, you indicate how many atoms of each element there are with subscripts, and that is the numbers that are beneath the symbol. So now we're going to practice writing formulas for these simple ionic compounds. Okay, so for our first example, we have magnesium fluoride. Let's analyze it. The ending is "ide," so I know that's a simple ionic compound. And the beginning of this word is fluor, so we know we're talking about fluorine, and magnesium, obviously. So first we're going to write the symbol and the charge for the metal. We have Mg2+. When you're writing the charge next to the symbol of the ion, you write 2+ rather than +2. Then we have fluorine, which is a -. And now we think How many fluorines do we need to balance out 2+ charge on a magnesium? And we know that we would need 2 fluorines, so we would write our compound as MgF2. That's magnesium fluoride. So our next example, we have tantalum phosphide. We know this is a simple ionic compound because of the "ide," and we know the nonmetal we're talking about is phosphorus. So let's locate tantalum because we got to name the metal first. That is number 73. I'm going to write Ta5+ because that is the charge on tantalum. And now phosphorus has a -3 charge. Now this one is a little bit more complicated because you can't just multiply phosphorus by 2 because then you'll have -6 and +5, and that won't balance out. What we need to do is find the least common multiple between the two. And that number is 15 because 5 times 3 is 15 and 3 times 5 is 15. So I know I'm going to need 3 tantalums, which will give me a +15, and 5 phosphoruses because that will give me -15, which will equal 0 in the end. So I'm going to write this out as Ta3P5. And now we know our charges are balanced and we have our ionic compound tantalum phosphide. I'm just going to highlight these answers, and that is simple ionic compounds. Next, we're going to move on to multivalent ionic compounds. And these are ionic compounds that contain a multivalent metal, which means that the metal can have multiple charges. So if you look on your periodic table, specifically for honors chemistry, not AP chemistry, your table will have charges on it. And if you notice, many transition metals have 2 charges, like vanadium has +2 or +3, iron has +2 or +3. And multivalent ionic compounds just mean we have to indicate which version of the element iron, for instance, we're using in our compound. Because like we learned with simple ionic compounds, the charge of the metal will impact how many atoms of the nonmetal element we will need, because ultimately the overall charge needs to be neutral. So it is very important that with multivalent elements, when you're using them in an ionic compound, you indicate which version of which version of the element you're going to use, because the charges change. So let's get into that, how we're going to name it. So we name the metal just like a simple ionic compound, and then we indicate the charge of the metal with Roman numerals. And then just like a simple ionic compound, we name the nonmetal and we change the ending to "ide." And like I said, the only difference from simple ionic compounds is that you're writing the charge of the metal with Roman numerals. So we have chromium oxide. And the way that you go about naming this, oxygen has a -2 charge. So I'm going to zoom in. I know we have -2 here, and I know we need +2 to balance it out. So I know that we're using chromium 2. So I know immediately the charge of the nonmetal, and I don't immediately know the charge of the multivalent metal. So I use the charge of the nonmetal to get me to the charge of the multivalent metal. If there was a different number of oxygens, that would change things, because then I would need to multiply the charge by the subscript and then figure out from there, based on if there are any subscripts for chromium or whatever, how many chromiums I would need. So that's just what I explained here, just in less words. There's one oxygen atom with a charge of -2. So the chromium must have a +2 charge in order to have an overall charge of 0. So we're going to continue with examples of copper, and you will notice here how the Roman numeral is really important based on the number of atoms of the nonmetal. So we're going to start with the charge of the nonmetal. We have phosphorus, and we have 2 phosphoruses, and phosphorus has a -3 charge. So I'm going to write -6. So we know we need +6 to balance out that -6, and we know we have 3 coppers. So if we divide the +6 across 3 atoms, each atom of copper will have a +2 charge. And from there, we can determine that we are going to be using copper 2. So I'm now going to write the formula. So we have copper, that's the metal. In Roman numerals, I'm going to write 2. And then we have phosphide. Don't forget to change the ending to "ide." Now in Cu3P, we still have 3 coppers, but you can't assume that it's copper 2 because the amount of phosphorus is different. So now we have just a -3 charge on the phosphorus instead of a -6. And if we still have 3 coppers, that means that each copper only has a +1 charge instead of a +2 charge, because we need to have a total of +3 in order to balance out the -3 and make the overall charge neutral. So the formula for this, we would be using copper 1. So I'm going to name the metal copper. Roman numeral will have the charge 1, and phosphide again. So naming is pretty straightforward. You just have to know which version of the multivalent element you're talking about, because that is going to impact the formula. Copper 2 phosphide and copper 1 phosphide are not the same compound. It always helps me first to calculate the overall charge of the nonmetal based on the charge of the element and how many atoms there are of the element, and then kind of work backwards to get the charge of the multivalent atom that we're using. So next we're going to talk about writing formulas. So we're going to use the Roman numeral in the name to determine the charge, and then we're going to write the symbol and the charge of the metal. Straightforward. We're just going to work backwards from what we did in the previous examples. Then you just write the symbol and charge of the nonmetal. Same thing, use the charges to determine the number of atoms of each element required, and then just write the formula. So let's practice. Chromium 3 nitride. We know we're talking about chromium, and we know we're talking about nitrogen. So, and we also know we're talking about chromium 3+, because it has the 3 Roman numeral. So I'm going to write Cr, and we have 3+, and then we have nitrogen, which has 3-. So the formula for that would be Cr(N). Next, we have iron 3 oxide. So we have Fe3+, because of the Roman numeral, and oxygen 2-. Now, this one's a little bit harder. We have to think of least common multiple again. The least common multiple of 3 and 2 is 6. So we know that we will need 2 irons, because 3 times 2 is 6, and 3 oxygens. So I'm going to rewrite this as Fe2O3. Now we can always check that these charges work out. We have -6 here, and we know that we're talking about iron 3. 3 times 2 is 6. So we have +6 here. And then the overall charge is neutral. Finally, we are going to talk about polyatomic ionic compounds, and then we'll have some practice combining all the ionic compounds. Polyatomic ionic compounds just include a polyatomic ion. And if you remember from a video way back, polyatomic ions are just groups of elements that form an ion. So to name them, they consist of a metal and a polyatomic ion. So we are first going to name the metal. And in this case, the metal can be multivalent, in which case we would still use the Roman numeral, like we did with multivalent ionic compounds. And then we are going to name the polyatomic ion. And the ending does not change. We do not change anything to "ide." So for instance, calcium carbonate will be written as calcium carbonate. Lithium chlorate will be written as lithium chlorate. Nothing changes. So that's very straightforward. You just name what you see. Okay, so for writing formulas for polyatomic ionic compounds, we first start with writing the symbol and the charge for the metal. And if you have a multivalent metal, you are going to use Roman numerals to indicate the charge. And then you are going to write the symbol and the charge of the polyatomic ion. And you'll know that it's a polyatomic ion because the ending of the name will be something like "ate" or "ite." And that's usually a key. There's a polyatomic ion. There are instances such as hydroxide that do not have the ending of "ate" or "ite, and you just need to know that that is a polyatomic ion. So then we are going to use the charges of the metal and the polyatomic ion to determine the number of each ion required, and then finally write the formula. Now with polyatomic ions, you can still use subscripts, but there has to be parentheses. So outside of the parentheses, you would write how many of the polyatomic ion is required in the formula. So let's try writing some formulas. First, we have nickel 2 oxalate. So we know we are talking about nickel with a 2+ charge and the polyatomic ion oxalate, and that is C2O4 2-. So I'm first going to start by writing the symbol and charge of the nonmetal, which is Ni2+, which I got from the formula of the Roman numerals. And then the same thing with the polyatomic ion. We have C2O4 2-. So we know we only need one of each for the charges to balance out and get a neutral compound. So I'm just going to write NiC2O4. Next, we have barium sulfate. So we're talking about barium and the polyatomic ion sulfate. So barium has a +2 charge. Sulfate is SO4 2-. So I'm going to write that down. And same thing with the first example, we know we're going to have one of each because the charges will balance out. So it will just be BaSO4. Okay, so I don't know if you can see this, but I changed the last example to scandium nitrate. So scandium has a +3 charge. Nitrate has a -1 charge. So I'm going to write, we need 3 nitrates to balance out the 3+ from the metal scandium. So I'm going to write this compound as SCNO3, 3 in parentheses like that. That is our practice with writing the formulas for polyatomic ions. Now you're going to do some individual practice. Okay, so you're going to practice naming and writing formulas for each of these compounds, and then we are going to go over the answers, and that will conclude this video. Okay, so let's go over the answers. I'm going to do a short explanation on each of them. First, we have zirconium nitrate with polyatomic ionic compounds. It's just naming the metal and the polyatomic ion, which we did here because this is nitrate. Next, we have cesium oxide. Same kind of thing. CS is cesium, and oxygen, we changed the ending to "ide" because this is a simple ionic compound. And finally, we have chromium 3 bromide. So we know that this is a multivalent ionic compound because chromium is a multivalent metal. So the way you would write the name for this is you would figure out that the bromine charge would be -3. And then we know that we need a +3 to balance that out. So we have chromium 3 bromide. Now we're going to do the writing the formulas. So I just followed the same steps that I discussed earlier when writing the formulas. So we have titanium 4 phosphate. This has a multivalent metal as the metal and a polyatomic ion. So we know titanium is going to have a +4 charge, and phosphate has a 3- charge. So we're going to look at the least common multiple, which is 12. We know we will need 3 titaniums, which will give us a +12 charge, and 4 phosphates will give us a -12 charge. So it will balance out and be neutral. And again, with polyatomic ions, when you have more than one, you want to use parentheses. So now the next one we have is gallium sulfide. This is a simple ionic compound. Gallium has a +3 charge, sulfur has a -2 charge. So same thing, least common multiple is 6. We will need 2 galliums, that will give us +6, and 3 sulfurs, which will give us -6. Finally, we have manganese 2 fluoride. So we have manganese, which is multivalent, and we know from the Roman numerals, it is manganese 2+. And then fluorine is a -1 charge, so we will need 2 fluorines to balance out the 2+ on the manganese and have an overall neutral charge. But I just wanted to do a little end of the video summary and practice to make sure you understand all the different kinds of ionic compounds I talked about. So that was the end of this week's video on ionic compounds. Next week, I'm going to be talking about acids and covalent compounds, and that will be wrapping up this unit on the different compounds. So if you need help with naming and writing the formulas for acids and covalent compounds, you can join me back next week for that video. I'm also going to leave a link in the description box to my website if you would like to schedule tutoring. And if you have any questions, feel free to leave them in the comments and I will do my best to answer them. I hope you enjoyed, and good luck with learning the rest of your chemistry.